I'd like to make some kind of micro adjustment jig for the rip fence. If, for example, you were trying to cut a piece of hardwood to make a sled runner, you really want to take off the tiniest of increments and take it off quite exactly to get a good snug fit. Now, I've got a dial gauge. It's on a magnetic base, but it's completely impractical trying to waggle this around and trying to find some kind of orientation in which it will let me measure the displacement. Matthias Wandel had a nice little micro adjustment gauge. What Matthias had was the block of wood that way and an on-off magnetic latch set into the block of wood. That way you could clamp it to the table, and then the business end of the dial gauge through this projection on the back here would go in a slit in the block of wood that you could tighten down. Problem is, I can't find any magnetic latches, so I'm going to have some experiments with some ordinary magnets and some bits of steel and see if I can make a magnetic latch. Got a couple of rare earth neodymium magnets here, keeping them a safe distance apart. They seem to be 1/2 inch by 1/4, and I have a piece of dowel which is also 1/2 inch in diameter.
Well, that was a mistake. Routing a slot in a piece of dowel is not the best idea. It turns out that chain drilling is much better.
Here's my 1/2 inch dowel with 3 neodymium disc magnets in there. Unfortunately, the magnets have their poles on their faces, their circular faces. Oops, shouldn't do that, not near a cast iron table. I'm going to look out on the line for some magnets where the poles are on the circumferences, but don't have any now. I've put a 1/2 inch, well, a bit more than that, hole in this 3/4 inch piece of wood, so we'll pop those in there. Now it's safe to go near the table, and here's a couple of pieces of mild steel. I don't have iron, I understand iron would be better, to act as the shunts or keepers. So what sort of effect do we get? Well, we would expect with the magnets like that the pieces of iron are acting as keepers or shunts. And indeed, it's not too difficult to take it off the table. Rotate it through 90 degrees and it does get significantly more difficult to take it off the table. Quite a bit more force required, so that's encouraging. Not a huge amount of force, so perhaps this wood is too thick. Let's try a piece of paper. You can just about see my mark there indicating where the slot is. And once again, being a bit more careful this time as my fingers are a bit close. Let's pop this down on the table. So quite a lot of force that way. Let's rotate it. Not easy. And the force is way reduced. So the distance is important. Of course, magnetism falls off as at least the square. I think I read somewhere the 4th power of the distance. Now, as I mentioned, the inspiration for this was in part Matthias Wandel's little dial gauge that magnetically clamps down to the surface, but also in part these things. This is a dial gauge and magnetic base from the metalworking lathe kit, and I've had someone send me a diagram of the insides of one of these, and the magnet apparently and the shunts are cylindrical.
I'm sure I have a piece of iron pipe somewhere that I can't find it, so I'm trying to get closer to a cylindrical pole arrangement using a couple of pieces of angle iron. I've flattened off a contact area, and then I'm cutting the angle in half. but it doesn't really work at all. Probably the pieces are almost touching and the two bits of angle iron are forming a complete circuit around the magnet. Well, let's have another look in the stock.
I found the iron pipe, 1/2 inch. Of course, 1/2 inch is pretty meaningless. Outside diameter is about 20 millimeters, 21, and the inside diameter is about 16. So quite a bit over 1/2 inch on the inside and way over on the outside. It's very easy to lose the coating on these neodymium magnets, and if you do, they'll start to degrade rapidly. So I'm just going to put a piece of paper in here and see if one's intuition is correct, that in a complete enclosure of iron, or steel probably, I doubt it's iron as I said, whether there's any magnetic effect leaks outwards, or whether it is like a sort of a Faraday cage for a magnet. Nothing. Nothing in any orientation. The next thing I'd like to do is to mill a flat onto the top of the pipe. This will accomplish several things. First of all, when this is the other way up and contacting the table, a flat surface on the pipe will improve the magnetic attraction. Secondly, it'll make it easier to cut through here because it's jolly hard work cutting through this iron pipe. And thirdly, having cut through here, we'll also have arranged a gap so that it's no longer a complete circuit around the magnet. Most of the time when I'm using this vertical mill, it's for plunging, and all my mills are actually slot drills. I don't have any end mills, but it should get the job done, we shall see. And if I wanted precision, which I don't need, I would take out the chuck here from the Morse taper and I would replace it with a proper collet. So I've milled a flat onto this iron pipe and I've cut a slot down the middle, halfway to making 2 halves out of it. I gave up on the hacksaw. I can't cut straight with a hacksaw. I put a 1/16 inch slot drill back in the milling machine and made that cut with that. My 3 disc magnets in a row. Not much force that way. Turn it through 90 degrees. Now there is some detectable force in that orientation. Okay, final part of the experiment is to now make it completely 2 halves and see what happens there. I've removed quite a bit of material from the centre here. I've noticed a horrendous seam down the centre here, but I found a piece of plastic from the inside of a till roll which will insulate my expensive magnet from rubbing against that. And I've also come across a neodymium magnet that doesn't have its poles on the circular faces but instead has the poles down the edges here. So let's pop that in here and rather gingerly place that on there, and even more gingerly, getting my fingers out of the way, place that on there. Hardly any adhesion in the horizontal position. Very easy to lift off. Adjusting it round to the vertical orientation though, my goodness, there's a lot of force there. So that's it, that's what we want. Well, none of these pins that look as though they might be brass or copper are brass or copper. They're all steel, and I'll try and avoid that. So what I might do in my little piece of wood here is to widen this and put a cocktail stick through to engage in the slot in the magnet here.
Well, I'm downstairs where the decent vice is. This is the sort of dirty metal filings area. And having sliced this iron pipe into two sectors and ground out an air gap, it's time to deal with the fact that it's actually slightly bigger inside diameter than my magnet holding little plastic tube. So I'm just going to use the vice to squish this up a bit and get that a nice tight fit, snug fit around the plastic tube. There are a couple of gaps to sort out here. There's a small gap in this air gap up here and a slightly bigger gap required down there to keep these two faces flat to the table to be. So I'm just going to put a cocktail stick between those two and a satay skewer between these two.
It turns out that the forces are sufficiently great that the pieces do move around in the wood, so a bit of epoxy is required.
Well, this disc sander is getting worse and worse, so I apologise for the noise. There is some adhesive, so it's not likely to go flying off, but fingers crossed. I think we'll have some dust collection.
I've remade the base to be a little bit smaller. With this large base here and the distance between the business end and the force, the moment is too great and there is a tendency for it to swivel around. And to improve the friction between the base and the cast iron top, I'm drying the glue that's holding the assembly in here with the magnet in the on position and with this end clamped down to the table to try and get everything just set in the flattest configuration possible.
Well, that seems to have worked fairly well. So you've made a cut. You'd like to bring the rip fence a tiny amount closer to the blade. You can pop the gauge down, switch on the magnet, zero the gauge, and then move your rip fence, say, by 0.1 of a millimetre. Each division on here is 0.01 of a millimetre. Now, the only problem with my setup is that this rip fence waggles about a lot as you clamp and unclamp it. So I'll just set another 0.1 of a millimetre and clamp it back up, and there is a bit of extra movement, so I'm going to have to learn to deal with that, but that's obviously the fault of this rip fence here and not the dial gauge and base. The cylindrical magnets worked pretty well. It's certainly convenient to mount the thing in here that way with the iron pipe pole pieces, but the earlier experiments showed that if you wanted to use 3 disc neos, that would work as well with flat pole pieces, no problem.
I suspect that putting the flat pieces and the dowel with the discs into the base would be a lot trickier. The downside, though, of the cylindrical arrangement, the cylindrical magnet and the iron pipe, is that being diametrically magnetized, it's not quite as strong as the 3-disc Neos would have been.